Okay. So what I'm going to do today is to make a presentation about Internet of Things on the one hand and smart grid on the other hand. So what you usually do when you give a presentation at a congress is, of course, to compare your presentation in your slides to the slides you have seen in before from the other presenters. So what I can promise is that I won't give a presentation about our products. So the product RWE has got, I think, is well known. So we have got energy, 230 hertz, 230 volts and 50 hertz. But I think that's not very interesting for you today. So to warm up, I think we can start maybe with some simple definitions I have taken from Wikipedia. So I think we have got a headline here today at the Congress, Internet of Things. So what is Internet of Things? So Internet of Things is a network of physical objects or things with electronic software, sensors, and so on, based on the infrastructure of ITU, Global Standards Initiative. So that is what Internet of Things is. So, and what utilities talk today about is smart grid. So you all know the term smart grid. And there, of course, the question is also again, so what is a smart grid? So a smart grid is a system which includes a variety of operational and energy measures, including smart meters, smart applications, renewable energy resources, and energy efficiency resources. So now the very interesting question is, so what do these things have in common, and do we have new challenges in this new field of application? So, and that is what I would like to stick in today. So what I would like to do is to provide some ideas, to provide some challenges and ideas, so where you might contribute to the problems which we have got today in the Energiewende or energy turnaround. So what you can see here is a quite simple model which we use within the community or within the utilities to enlighten or to show how ICT is working. So when we are talking about information and communication technology, we of course have got very interesting topics which we already had got here on our agenda, like Green Pocket has presented in the area of energy management or smart home, of course. But on the other side, you have got very traditional and classical infrastructures we have to operate as a utility. And so in this picture, or in this figure, you can recognize we have got two different types of ICT. So on the one hand, you have got the e-energy field, you have got trading, you have got smart home, e-mobility, you have got storages and so on. But on the other side, you have the classical grid topics where we are talking about the distribution network of the utility. And you can imagine that this topic, so the latter one, the operational IT is a critical infrastructure. So we have to differentiate between operational IT, so-called OT on the one hand, and between information technology on the other hand. So the use cases we are today addressing are shown here. So we have got night heatings. It's very boring to talk about night heatings, but we have got a lot of them in Germany. So 1.4 million is one figure. When you look it up in other studies, they are talking about 2.2 million night heatings. So that is quite a lot when you talk about machines you want to control. So then you know the topic dynamic tariffs, you know street lighting, grid control, virtual power plants. So that are use cases we are addressing today within the smart grid. And there the question is, so do we have a relationship to Internet of Things? So is that all taken to the Internet, and do we take ITU technologies to solve the challenges we have got within the energy turnaround? So in the grid infrastructure, we have got a grid control center. We have got so-called Schutz- and Sekundärtechnik in German, so you would call it secondary technology in English. You have distributed energy resources, and you have got prosumer. So it's a prosumer. You can see I've put an internet bubble there. So I would say, okay, there we are using internet technologies, of course, and information transmission is done by utilizing the World Wide Web or classical internet technologies. But on the other hand, you will simply understand that the control center within a DSO, within RWE, is not connected to the World Wide Web or to the internet. So that is clearly a critical infrastructure. We are operating in the background, and the other stations we have got in the systems are partly critical, of course. So a single PV panel is not really critical, of course. But when you take them all together, you will have got a critical power where you can say, okay, the aggregated stations are also critical. And that is a major challenge we have got in today's world and within the energy turnaround. Then we have got very interesting innovations within the smart grid. So we have got smart operator, for example, which we integrate into the low voltage domain in order to receive sensor information about the grid itself, and also to make a kind of power control where you want to balance feed in on the one hand and load on the other hand. You have got intelligent substations, smart metering, e-mobility, electric storages, and intelligent loads. So all these topics might be an element of Internet of Things. So their internet technologies are utilized to solve the problems which we have got in future. So what I would like to do, now is to talk about the smart metering aspects in more detail. And also there's a question. So when we will have a smart meter rollout in Germany in 2017, the question is that really critical for the system? And do we have any issues we need to consider? So what we can see here is a technical figure I have brought to you. So I hope it's not too technical. That is a presentation or a figure taken from the Federal Office for Information Security, so taken from the protection profile. The protection profile describes how we will do the smart meter rollout in Germany starting from 2017. So you have got a home area network on the one hand, where you will find the PV panel and the loads you have got at home. You have got a world area network. I think all of you know what that is, consisting of a smart meter gateway administrator, a controllable local system management, CLS management, and so-called external market participants. So that could be a distribution system operator, for example, or your supplier where you buy your energy. So, and on the right side, you have got the local metrological network where you have got the meters. So when we simplify this figure, you will see we have got the external market participants connected through wide area network, and that is connected to the so-called smart meter gateway where you operate your smart meter. So that was the world, I think, 2 years ago. So everybody in Germany talked about smart meter rollout, and smart meter rollout was only to take the meter readings from the customer and transmit those readings to the back-end system. So and afterwards, Ernst & Young made a study, and the result of the study was only with the readings, only with measurements, it won't be very beneficial to make a rollout within Germany. And so the idea was born to make control, or to put control also onto the system, and to enable switching functions by exploiting the smart meter gateway. So the switch box or control agent was born, and now we are facing the problem that we need to integrate an additional element to this measuring infrastructure. So we call it in German Steuerbox, so I just translated it to switch box. So what is a switch box? So you have got 4 relays in this box, and you have got some hardware, CPU, RAM on this board, and you can operate it, this device also as a intelligent agent if you want. So here you have got the amount of stations which will be where we will do a rollout in Germany. So we have got the night heatings, 2.2 million in Germany. You have got the so-called 14A stations in some, but also the PV panels. So at all will have 3 million stations in Germany, which will be interconnected within the system. So that is a major challenge. So the challenge is to operate not only a meter through the smart meter gateway, which is provided by the German ministry. So the challenge is when you have got such a device at home, you will see an Ethernet port at your smart meter gateway, and what will you do as a customer? You will say, okay, Ethernet port, I will take my patch cable and put my Fritz box from AVM onto the smart meter gateway, and I will try to surf through the internet through this smart meter gateway provided by my DSO for zero money. And of course, I have got my television, my laptop, smart home application within this network. And on the other side, I need to operate my switch box in order to make control for night heatings and PV panel. And so here you can see a major problem which we have got. You are not able to make a separation between the different domains. So on the one hand, you have got multimedia applications at your home, and on the other hand, you have got applications that are operated by your DSO. So from IT security perspective, you need to establish a separation, so where you also have got very clear responsibilities for both domains. So another problem is when you would like to establish this separation correctly, you have to say, okay, you also need a physical separation. So you need a logical separation in the IP4 world. You need different subdomains when you're not working with IP version 6. And on the other hand, in order to address IP spoofing or denial of service attacks, you also need a separation through a managed VLAN switch. So, and this is taken to the customer, and then you have to imagine, okay, this installation needs to put on the wall, and also you have got the hardware, and that needs to be paid. So it's really a major problem when you say, okay, who wants to pay this infrastructure only to make control for your night heating or for your PV panel? So this is a figure taken from VDE. So here you can see the amount of feed in Germany. You can clearly recognize that most stations are in the low voltage domain. So, but also with 7,000 megawatts. So that is quite a lot. So what would I like to say with this slide? So when you say, okay, a single PV panel is not really critical, so what are you talking about? So nobody is interested. I would say, okay, you're fully right, but take a sum, and take the sum of all these PV panels in Germany, do an aggregation of this, and imagine someone is hacking the back-end infrastructure and has got control of all these stations. So then you have to say 17 gigawatts is quite a lot. So every switch you are doing in the energy grid that exceeds the 3 gigawatt threshold leads to a blackout. And that is a risk we are addressing. And so we need, of course, a solution that is economic meaningful on the one hand, but also a solution that is not that is not a risk for infrastructure and is leading to a blackout. Okay, I would like to come to my summary. So do we have Internet of Things and smart grids? Yes, we do. However, Internet technologies will be integrated in selected subsystems. We will have in the energy grid systems which are today separated from the Internet and which will be separated also in future from Internet, but also where different technologies, not Internet-based technologies, other technologies are used in order to make the operation. So what are the key challenges which we have got? So we have got a metering infrastructure in Germany that is described by Federal Ministry of Economics or by the BSI, by the protection profile, made for meter readings. And we have to extend these specifications and we have to extend these systems with reliable solutions to make control for PV panels and night heatings and wind energy and so on. So, and last question, what are the next technical steps we have to face? So elaborate interoperable and standardized systems. So that is very important because we have got 1,000 DSOs in Germany, and on the other hand, we have got 1,000 suppliers in Germany. So now you can draw lines between all these entities, so you will recognize that a lot of interfaces you have to establish. So no one wants to program all these interfaces, and so a standard and standardization is very, very important here in terms of economy. So, and then enable communication networks for the smart grid and for smart metering. So I think that is very important for you to know what we are doing there. So we have got about 3 million systems that will be controllable in Germany, but that is only 50%, so you can make twice of it. I would suppose that we have got around 8 million devices that need to be interconnected within these cellar installations or at the basement for the smart metering infrastructure. So, and at the end, ensure sustainable security and reliability of the energy grid. So, have in mind, so we have got a blackout risk, of course. So, if you had got some connections or some information about information security, IT security, you know 100% security is utopic. You will never reach it. So that is impossible. But we have to work on a system that has got the reliability which we have already today, and that is very good. So that's it from my side. Thank you very much.